All right, I'm back. We're at the bottom of page 277. And if we read the preamble before this, you'll see why this question is here. So a few years ago, it was like a lot of years ago at this point, a problem really similar to the following showed up on the AP Calculus exam. So many students got it wrong, they ended up not counting the question. There's really no excuse for that. So I'm going to make sure that you guys, when you see that question, can answer it and get those points. So all it is to find the horizontal asymptotes of this thing, right? So the number one mistake that people make is they think that all things are rational functions. In a rational function, you only need to go to infinity. This is not a rational function, so we need to go to infinity and negative infinity. The second thing they get wrong is they just don't know how to deal with it, right? But we do know how to deal with it because we've done problems like this. That's basically how learning works. Someone shows you something, you're like, oh, now I get it. And the next time you see it, you're like, I've seen you before, then you just do it. So here we're gonna go to infinity, go to negative infinity. So I'm gonna start with infinity, I guess. Limit as x approaches infinity of 5 minus 4 to the x over 1 plus 4 to the x. All right, going to infinity, I think like high-powered stuff, whatever's going fastest will have the most bearing on what's going on. So I'm gonna divide through by the highest powered thing in the denominator. So limit x approaches infinity of 5 over 4 to the x minus 1 over 1 over 4 to the x plus 1. All right, 5 over 4 to the x goes to 0. 1 over 4 to the x goes to 0. So all I get is negative 1 over 1, negative 1. So what did we find? We found, therefore, y equals negative 1 is a horizontal asymptote. Okay, that's as we go to positive infinity. Let's go to negative infinity. So negative infinity, I like to do these a little differently. I like to think of the graph. So it'll be 5 minus 4 to the x over 1 plus 4 to the x. All right, so I like to think of the graph of 4 to the x. So 4 to the x looks kind of like this. Really, just in general, a to the x looks like that. So like put that one in your mental encyclopedia of graphs. It's an important one. In particular, it's important because of that limit to negative infinity. Like you can picture the graph, you can picture the limit, you know the answer. So here, okay, if I'm going to negative infinity, 5 does not have any x's in it, so it's just going to stay 5. 5 forever. 4 to the x, you can see the limit as x approaches negative infinity of 4 to the x is 0. The limit as x approaches negative infinity of a to the x is 0. It doesn't actually matter what a is, but in this case it was 4. So we get this. So minus 0 over 1 doesn't care. There's no x's. 1, and then 4 to the x again, 0 again. So we actually get 5. Therefore, don't forget to answer the question, right? What are the horizontal asymptotes? Y equals 5 is a horizontal asymptote. There you go. All right, so we found both of them. Most people would find only one. Going to positive infinity is like much more popular amongst the student crowd than going to negative infinity. I mean, it's probably more popular amongst like all people, but like who knows? I only have experience with students doing these things. So now what I'm gonna do is switch over to calculator. Look at this graph just to like get a sense, like what is happening with this thing? So this is we're having our relative growth rates competition, if you recall. 2 to the x1, exponentials will always win over polynomials, which will always win over logs, which will always win over trig functions, by which we mean sine and cosine. So I'm going to insert a new problem, doc41. And what do I want to do? I want to graph. All right. So I'm going to graph 5 minus 4 to the x over 1 plus 4 to the x. Okay, it's an interesting graph. I feel like for better sense of things, I should also graph. So hit tab. I'm also going to graph negative 1, which I knew was the limit as I went to infinity. And then I'm going to graph 5, which I know as the limit. I know that 5 is the horizontal asymptote as I go to negative infinity because I found that. All right, that looks good. Let's zoom out and see like what's going on here. Is this in any way, what am I doing? Zoom out. Zoom, it's like by default, I just go to zoom box. Zoom out, center. Not terribly exciting. Like it gets to its asymptotes, or it approaches them very, very quickly. What's this point here, right, where it hits the axis? Can we solve that? I think so. Let me just do this. So I'm gonna add 0. I'm gonna do a menu 814 for intersections. Click, click. I get 1.61 basically to 3 decimal places. Let me switch back. So we don't need to do this, but you need to be able to do this. So I think it's a good time to do it. If I wanted to know the intercept, the x-intercept of this thing, so we're going to find the x-intercept. Not related to the problem, really. The x-intercept. So y equals 0, right? So my equation is 5 minus 4 to the x over 1, 5 minus 4 to the x over 1 plus 4 to the x equals 0. All right, so my first step, that denominator, you're gone, right? I only need to know when the numerator is equal to 0. 5 minus 4 to the x equals 0. All right, so then I'm going to subtract 5, divide by a negative, so or just add 4x to both sides, actually. 4 to the x to both sides. Easy thing. All right, now what I do. So you might be inclined to use log base 4. Like, that's not the worst thing in the world, because like it'll work. You should use natural logs. You should always use natural logs. So I'm going to use natural log of 4 to the x is the natural log of 5. And then exponents become coefficients. And then x is the natural log of 5 divided by the natural log of 4. All right, so let's go back to the calculator and just see if that's actually the same numerically as what we have found on the calculator. So here we are. I'm going to go doc4. I'm going to insert a calculator page and just really quickly do a solve. f1 of x equals 0 for x. Let's get the exact value. Okay, so now why does this look different? So I got the natural log of 5 divided by the natural log of 4. Let me just hit enter. Same thing. What's happening in that denominator is that the calculator is rewriting 4 as 2 squared, and then the exponent is becoming the coefficient. So 2 natural log of 2 is the same as the natural log of 2 squared, which is the natural log of 4. So we got the same value, which is this to 3 decimal places. And so I think that's really good. It's good to be able to do that. It's good to think about it. I'm definitely going to wrap this up here and come back in the next video to do more. We're going for it. 329 pages. Started on page 209, so not all of them, but a lot of them. All right, so I'm gonna end this here. See you soon. Hope these are helpful, all that stuff. Yep, later.